Okay, start out with a couple of reminders. The difference quotient I'm going to be writing as with different letters because I got Y instead of F and T instead of X. So we have multiplied out x plus h a few times. T plus h is the same thing. Don't forget the middle term. Don't just distribute the exponent because then you're filling instead of full wheel and yes, whatever. Okay. Okay, so what is y of t plus h? Let's just figure that out. Okay, negative 4.9 times 2th is negative 9.8th. That is so freaking long. Oh well. Remember, a lot of it cancels. And we're about to learn a better way. So, don't forget it's f of x plus h minus f of x, or y of t plus h minus y of t. Don't forget to subtract off the original. Okay, and then what cancels? Lots of things cancel. Anything that doesn't have an h should end up canceling. Negative 4.9t squared, 12.5t's, 1.8's. Yep, they're all gone. And to save a little bit of space, I'm going to factor an h as I go out of what remains. I'm going to cancel an h and plug in 0 for remaining h's. And we have a velocity formula. Incidentally, 9.8 is meters per second squared is gravity on the face of the Earth. Actual real number. Wow. Okay. Why does the upward velocity have to be 0 when something's at a highest point? Well, think about it this way. If the velocity is positive, you're still going up. If the velocity is negative, you're already coming down. So to get the maximum height, we take v equals 0. So we have a velocity formula. And we set it equal to 0. Spiffy. That's approximately 1.275. Okay, so how do you find the actual height? We just found the time, labeled t. To get the height, you go back to the original function, you graph y, and then trace. So just to remind you, we'll have to use x's on the calculator because it doesn't understand t's when graphing. And when we trace, we get t is 1 point. Oh, we're tracing. I like to trace at 12.5 over 9.8. Notice you don't have to turn it into a single decimal when you're tracing. And the actual height is 9.772 meters. Oh, look, write an equation for the tangent line. I really strongly suggest point slope form for the equation of a tangent line. We're going to use the difference equation to figure out what the slope is. The point, let's see. We plug x into the original to get the y value, and we plug x into the difference quotient to get the slope. Okay, so and we are pretending that we have already calculated the difference quotient. So just because life is too short to do all those limits again. Once you've done that, the tangent line is just, okay, let me fill in the blitz for you. I really prefer point slope form because you plug in the point. Let's see, what do we have? 3 comma negative 3. X coordinate of the point goes closest to x, y coordinate goes closest to y, and the slope goes in front of the parentheses. You know. There you go.